All right. Well, welcome everyone to week 2 of ARM 55. Tonight we'll be going over chapters 2 and 3. As I indicated before, or at least in the email, that these two chapters are actually might take us a little bit more than the 90 minutes, but we'll try to stay on task as much as we can on there. If you do have any questions throughout, please go ahead and either raise your hand and I'll unmute your line, or you can type in a question as well. By all means, if there's something after the class that comes up, you can also email me separately, and then I can also get those answers out to the rest of the group as well. So going right into it. So tonight we'll be talking about root cause analysis. And for those that haven't done root cause analysis, or you might be familiar with it, it's probably, at least in my view, it's either the most misunderstood or most underutilized aspect of really trying to discover problems. And people really probably don't do it all the way to the root cause. They do a partial, and they think they got the root cause, and a lot of times that's not it. I will probably add some caveats of my own personal opinion, even though when we talk about systems a little bit further on, that you might go to the root cause, but usually it's an underlying system, structure, or organization. It talks about there can be different causes of what the root cause. It can be people, machinery, those type of things, or it can be systems or operational areas. And in most cases, I believe it's more of a system aspect. It's usually a policy that encourages wrong behavior. In some cases, that becomes part of it. For the learning objectives, as you get used to how we do the classes, we'll be covering the educational objectives. And even though this was a long chapter, I guess the thing I'd probably tell you is not to be too scared, because one of the things that, again, when you look at the material, I always remind people to take a look at the 50,000-foot level. You know, what's the concepts that they want you to understand? Do they want you to know step 5 of how to do that? You know, if you understand the concepts, you'll probably understand what the flow is. And what they talk about in here is explain how an organization can use failure mode and effects analysis to assess and mitigate risk. So, and then how can an organization use fault tree analysis? So if you understand how it can be applied, that's the most important concept, which then also will help you kind of understand the details, because each one looks at a different area or has a different purpose. And so the questions you're going to get on which technique would you use for this situation when you're looking at more human factor type issues? Well, if you read the text, human factor issues will probably be the 5 whys and the fishbone. Where FMEA, or failure mode analysis, is going to be more for processes or large complex systems, is probably where you use the failure mode analysis. So that's the idea, is when to use it, how to use it, and then there'll be there's some areas which I most likely know that will probably be on the exam as well. The other part of it, as I remind people when you start reading the text, is you want to look at the educational objectives and then read the summary. And if you look at the summary page, it wasn't even 2 paragraphs. it was a fairly short summary of the chapter. And that also gives you an indication of, okay, how much detail are they expecting you to know in there. And there's a lot of information, but a lot of charts. And hopefully through tonight we'll make a little more sense of some of those different areas. So when we talk about root cause, really what we're looking at is the event or circumstance that directly leads to an occurrence. And typically we think of root cause traditionally, or at least in the safety side, it's what led to an accident, what led to a failure, those type of things. So when we think of, and they use a lot more acronyms, RCA and those type of things, I don't tend to use those, but if they're using them in here, they may use it on the exam. And that's the other thing to be cognizant of. If they use acronyms on here, a lot of times they won't even use the words. They'll use the same acronyms on the exam and expect you to know what RCA means. So I'll try to get used to it as well, but usually most people don't refer to it that way. But when we think of root cause analysis, it's really a systemic procedure that uses the results of the other analysis techniques to identify the predominant cause of the accident. And really what we're looking at is used to determine the underlying cause of a harmful event and to prevent such events from occurring again. Now, where the first definition was specific to an accident, really what we're going to focus on is it's the underlying kind of harmful event. Because a harmful event could be to the operational objectives. It doesn't have to be an accident. There's other things that can be harmful to the organization, and that's the way I really want you to think about it. And it's typically, as it indicated, used after an event has occurred, but can be used to predict events that could harm an organization. And really, where this is useful, going back to last week's class when we talked about the different theories, and if you look at Heinrich's and theory and some of the other things, if you start looking at events that maybe it was a near miss, and if you use root cause analysis, even though it didn't result in a maybe a loss, it could have. And that's really where you want to try to use some of these things from a root cause standpoint of identifying before it becomes a major event, as it talks about before. And the goal here is to learn to solve problems before they become major events, also rather than reacting to them as they occur. If we have a plan in place and we have an idea that, hey, there's a potential for this through our root cause analysis, we may have some of that. The 4 basic characteristics, and again, always, anything in a list, typically, if it's in a list, it says 4, and the 4 major characteristics, that usually means that's something that you probably want to memorize, because that's a key element when they start doing things in a list or saying those 4 areas. So when we think of the characteristics of root causes, a root cause is specific to the underlying cause. It's not a generalization. And typically when people do accident investigations, they say, well, the person was inattentive, or they need to be trained more, or something like that. It's pretty general. It's not, it doesn't really tell you much. And so that's not a root cause when we do something like that. It should be reasonably identified. And it must be expressed as something that can be modified. And when we talk about that is the root cause, and I put there cannot be an act of God, because it talks about, well, an earthquake. If the cause was an earthquake, well, what can we do? I mean, the root cause, that's not anything we can deal with. We can deal with maybe the bracing. We can deal with other things that the root cause was we didn't provide proper, things to secure our shelving and things like that, because the earthquake might have been part of it, but the root cause was the falling of the shelving or something like that because we didn't secure it. That's something we can actually do something about, whereas earthquakes, floods, fires, a lot of things we may not be able to. And also must produce effective recommendations for prevention of future accidents that stem from the root cause. And I also think that's an important one, because I always, when I do inspections, or in the past when I've done inspections, a lot of people would, let's say a cover off of electrical outlet's missing. And you say, okay, well, you need to replace the electrical outlet. And, the root cause is, well, there's a cover missing. Well, no, that's not the root cause. We can identify that all day long. It's a maintenance issue. It's it's something else that's going on. Otherwise, we're going to see the same problem over and over again. And so when I see, a building, and we kept on seeing that, well, that's an operational issue. There's something going on where people aren't doing inspections, could be the root cause. That no one's taking accountability or responsibility for that. And that kind of goes back when I mentioned about a lot of things are operational issues. It's because of that. That's the aspect that really comes to mind. Harmful events are usually associated with one of the 3 basic causes of loss. And so the 3, again, a list, what are the 3 basic causes of loss when it comes to root cause, where you might categorize them? It's either going to be physical, human, or organizational. So when we think of physical, well, that's pretty easy to think of. It's a failure of a tangible or material item, typically a piece of equipment. Something failed. And because of, well, in the news, and we'll mention Southwest later on today as well, but, okay, the nose gear on the Southwest, okay, well, it was a failure. Well, what's the root cause? That's what NTSB looks at. They're trying to figure out, okay, what happened? Is it a maintenance issue? Or actually, the other thing that happened a while back, there was cracks in the fuselage of the Southwest planes. And so when we think about, and all of a sudden they identified more cracks. Well, the preventive maintenance schedule typically for a Boeing 737, as an example, had so many touchdowns and landings. This was the criteria, was the typical criteria that Boeing gave maintenance organizations to say, here's when you want to start checking on these issues. Well, what do we know about Southwest Airlines? They do a lot more short flights. They're doing more takeoffs and landings, so there's probably more stress on the aircraft. So what happened after that incident, they said, no, we have to increase the PM schedule, preventive maintenance schedule now because now we know there's more stress put on these aircraft. And so again, that's what the root cause, when we think about it, we go look for what the challenges are, and that's how we can now fix it. So again, that would be a physical example. A human cause would be human error in action. So in this case, it's not performing a specific activity that, it's because texting while driving, something like that. We can identify, and sometimes there'll be multiple kind of root causes as well when we go through this. And the last one I put, organizational, faulty systems, processes, or policies. That we didn't have a policy saying you can't do this. In the example they kind of give, the policy that we say you shouldn't be eating while driving or something like that. But what I also would say, and I'll use this example that we typically see, unfortunately I would say in a lot of university systems, it's not just UC, is what I call the recharge system. So most people understand that when you want something done, you have it done, and then you get charged for it by, a lot of times, facilities. That's how they operate, is off a recharge system. Well, for researchers, they don't want to use their grant dollars possibly for, getting things fixed or putting something new in. And the example I'll give is an aquarium that a researcher wanted to put in. Well, instead of didn't want to pay $2,000 for facilities to come out and hook up all the electrical, he sent some students out to Home Depot and said, okay, let's get all the parts and let's hook everything up. Well, of course, something that wasn't grounded properly, and they started getting shocked. Now, if you do the root cause, someone would say, well, it was because the grounding wasn't done properly. And this is where I kind of go back. If you go back to the root cause, the only way you're going to solve the problem, it's really the recharge system itself that encourages people not to pay to have it done correctly. And so what I see is you typically see, unfortunately, you're encouraging bad behavior because of behavioral economics. So that can be an aspect, but a lot of people don't dig down that far when they think root cause. They say, nope, that was it, because we can fix the grounding issue. Now, how can we fix a recharge system? That's a huge thing. It's not just something that's going to be simple to solve. But I would argue that a lot of the things we see are based really on the systems that are in place. That, and recharge might be one example, and there might be some other things that people can think of as well. Also, just mention for those that did download the PowerPoint earlier, I realized that I included some chapters when I plugged in some stuff, so skip over until you get to the right page here. The nature of root cause analysis. So one of the things it talks about in the book that it tries to give some examples of is, again, traditionally on the safety side, we think from an accident standpoint when we do root cause analysis. But they give some other examples of how you might be able to use it in other areas. So obviously safety, originate from accident analysis for production. It revolved from quality control procedures for industrial manufacturing, of finding out why are we getting so many widgets. 10% of our widgets are, not to our quality standards. So what are we going to do to fix that? So that's where it would come into place. Process-based, similar to production, but it might include business processes of why are we, error rates maybe on processing paperwork, expense reports, something like that might be part of it. Failure-based, stems from failure analysis, and we'll talk more about that from an engineering. And then systems-based, which deals more change management, risk management, systems analysis, which we talked also about last week. So the typical basic steps in the root cause analysis process, and again, this is something, there's charts and all these steps. The first step is data collection. We can't identify root cause without complete information about the circumstances, causes, facts that were around there. So we need to make sure we get all of our facts straight, or at least as much as we can. Once we have that, we can start charting the causal factors. They kind of show, some mapping and flow charts of how that may look, and we'll talk about that. But, flow charting, I always encourage people to draw diagrams, because it really does help when you start thinking of from a root cause, what led to what situation, and that's what they encourage as well. So once we provide, some causal charting, we kind of, we identify the different steps of what may have happened. Then we start identifying the underlying reasons for the causal factor. and then that's where more really the mapping comes into play, and then we'll make recommendations as part of that. Now, of course, you can't see the really small stuff because we'll go into detail in each one of those. But of course, we see the data collection. You can have multiple sources of data that are at the top. Then we do the causal factor charting, which we'll discuss a little more detail. And then we start taking each one of those causal factors and do root cause identification. And again, causal factors are the agents that directly result in one event causing another. Now, a lot of times there might be, they talk about directly resulting, and sometimes it can be, I also believe it can be indirect resulting, that one thing led to another. At least from a legal standpoint, there's connectedness, I guess if you want to call that. But at least for purposes for the text, they're saying directly result in one event causing another. And then again, we talked about some of the recommendations here. So the example they give in the book, and I'll just read this briefly, a couple things, but and we'll go through it. But George drives a delivery truck for New Space Furniture Store. He was recently hired by New Space, but previously worked in the same role for another furniture store. While making a delivery on a rainy afternoon, he encountered a yellow traffic light at an intersection. He applied the truck's brakes, but according to George's statement, they failed to catch. His truck slid through the intersection after the light turned red, striking another vehicle. The delivery truck sustained indented front fender and flat tire. The other vehicle sustained greater damage. Both drivers were injured, and the risk manager from New Space must determine the causal factors. Now, as we go through here, I'll kind of go through at least what I feel is one thing they should have included in here. So the first thing is these are the facts. George approaches the signal light turns yellow. These are the things we know from the data. What these little extra boxes are is kind of the questions you want to ask. Was he distracted? Was he driving too fast? Those are the type of situational things we have there. And then we have some other parts. Delivery truck leaves store. Well, who is responsible for the maintenance of the truck? So again, it's kind of making, these are the questions that aren't inherent. And one of the things that Emily brought out was, well, was the other driver distracted? And, good point. Well, does that really matter? Was the other driver distracted? Because either way, our truck hit the other car. The only where it would make a difference is, well, if the other person was also distracted, possibly, then maybe they could have avoided the accident. But there's really nothing, when you think about it from root cause, how can we affect that person's behavior? We can't. So it's kind of one of those things that I kind of think is a little red herring that they kind of put in there that may not really have much to do with that. So the one part that I want to point out, though, in here, it talks about the brakes did not catch, and they kind of put in parentheses. Well, when you think about it, the example that they gave, they keep on focusing on the brakes and the examples, but what about delivery on a rainy afternoon? Okay, so maybe they didn't catch. Maybe it's the tires. Maybe it was, so even though it goes to the braking example, we focus a lot on that, and that's what they're doing. Again, that can kind of show that, well, there can be some other factors that may be part of that as well. I would suspect a lot of times what they do in the text is they'll use a similar type of example, and they may use something very similar to this and have you do, try to determine, what would be the results of some other areas. So once we have, so by the way, the other thing on here is the CS, or the causal factors, saying, okay, brakes did not catch. These are the things we want to investigate more. So why did they not catch? The other car enters the intersection, and the car hit, and the truck hit the car. So that's where the causal factors they want to look at. So here's the first one, equipment difficulty. And you do this for each one of the various issues. So could it be that the brakes didn't catch, so to speak? Is that a brake maintenance problem? And then you start going, okay, were there procedures in place? Accountability, inadequate training. So if we find out that maybe they did have procedures, but were the procedures faulty? That no one's, we had a new person doing it or something like that. Who's supposed to be doing that? Or there's no training as part of that process. And then you have the other issue of the vehicle misuse problem, that the person driving, maybe because of the type of brakes they are, maybe you have to pump the brakes. Maybe there's some other aspects that the person wasn't trained. So it goes through all these different things. And so really the idea is to walk through and look at those specific areas. And again, when you think of a plane crash or something, that's what they do is they say, okay, let's look at this one specific area. What could be all the factors that lead up to that? Now in the summary, what they do is causal factor 1, and this is where kind of the first part where it showed the CF in the very first one, that the brakes did not catch. And so the determinations, brakes failed to engage, and then the recommendation is re-examine preventive maintenance procedure, replace brake pads, drums, fluid on predetermined basis. So if we determine, so even if that maybe wasn't, and this is where it kind of goes back to help prevent future incidents, even though maybe some of these weren't the exact root cause, it could have been one of the root causes. And the idea is to look at each one of these things to say, okay, they could have led to this, and so do we have these things as a solution that we can still make the process better from the future? Equipment reliability program, design less than adequate, procedure inspect, maintain brakes was not adequate. On the other car enters intersection, George was drinking coffee at the time of accident. So the idea, what this is going for, even though they kind of put that red herring of was the other person distracted, we're really not focusing on that as a causal factor. What we're focusing on is actually that George was drinking coffee at the time of accident, may have not been paying attention. Should we be allowing people, as we know, actually eating and drinking is actually just as bad as texting in a car in many cases as being the distracted driver. And so maybe part of that is standards policies. He maybe hadn't been trained on defensive driving, which would also include it that you don't drink or those type of things, or how to avoid an accident. Also considering if it was rainy, how fast was he going, might be part of that. That would be part of the defensive driver training as well. And then again, the last one, truck hit car, was he able to avoid it? And it kind of goes through, consider alternative strategy, implement accident policy, come through to contact. Now, consider alternative strategy for delivering merchandise. So here's something, again, from a risk standpoint for most people don't realize, but UPS, they try not to make left turns anymore. And the reason why is because of the amount of idling. I forgot how much fuel. There's actually an article I'll have to pull up, but they save tons, not only in time, but also in fuel consumption, because now they try to make all the delivery routes with right turns. And again, that's, if you look at risk, as an efficiencies or risk optimization, root cause analysis, why are we using so much fuel? Well, this is a process that this can also be used for when you look at different ways to do things. So now we go into really the other types of techniques. So that's the broad sense of what root cause analysis is. Now we talk about failure mode and effects analysis. So FMEA, and again, they use the acronym, so you want to know FMEA. It's an analysis that reverses the direction of reasoning and fault tree analysis by starting with causes and branching out to consequences. And you think that if they talked about that in the beginning, you talked about fault tree analysis before you did that, but that's the way they do the definition. So again, the idea is the cause. So the idea is what's the fault or what's the failure. So I'll give the example in this case. What I would look at is, okay, the shuttle. We know the O-rings, they talked about with the Challenger disaster. They knew the O-rings was a potential area where you could have a catastrophic failure. That was done through a failure mode and effects analysis, that they knew that under certain temperatures, these conditions. And so what you do is you start off, okay, if this component fails, what could happen? And you kind of go through each of the different levels. Whereas when we talk about FTA, it's actually saying, okay, something explodes, what are all the causes that could cause the explosion? It works in the opposite direction. So this one looks at a failure-specific piece of equipment and says what can happen. So again, this is something where it's used for, primarily used in product development and operations management. So when we look at all these different techniques, there'll be a question of which one will be used for which purpose. This one is in product development and operations management. And again, used to identify failure modes and perform effects analysis, and obviously that's where it gets its name. So what's the failure mode? It's the manner in which a perceived or actual defect of an item, process, or design occurs. Again, what's the failure of an O-ring? What's the failure of this? Whereas the effects analysis, you say, okay, we say the failure's consequences. We want to find out, based upon this failure mode, what are the consequences of this one piece failing, and that's what it looks at. This goes actually in a lot more detail than it had in the past, which I think is good, because it talks about indentured level. which is an item's relative complexity within an assembly system or function. And so you can have a level 1, you can have as many levels, 20 levels. But the idea is level 1 is going to be the entire system. And we'll use a car for an example later on. But we say, okay, the car's level 1 is the car drives. So a level 6 might be the pistons, or it might be the fuel pump, or something like that. That could be that's a part. You kind of think of each of those components. Well, the fuel pump is part of the overall engine, and we think of all those different areas. The local effect is the consequence of the failure mode on the operation function. It talks about these same things, or status of the specific item or system level under analysis. So the local effect is if it's a level 6 local effect, that's the failure that we're looking at. And the next higher effect is, if it fails here, what happens up this next level? And then the end effect is, okay, we know that it happens here, but ultimately what's the problem that happens? So if you think about parts of a car, okay, if we have a failure of the windshield wipers, so what? So the idea is when you look at the failure, and so what they do is they look at each part. So when you look at why these systems cost so much to build, is because they're looking at, if this failure, what's the criticality of that failure? Okay, windshield wipers stop working. Okay, during the summertime, probably doesn't really matter. Okay, during the wintertime, we get more rain. Yeah, I'm not going to be able to see, those type of things. But it doesn't necessarily affect the operation of the car. Whereas if my fuel pump goes out, does it affect, so there's critical components that say, okay, the function, the operation is I'm supposed to be able to drive this vehicle, and if that goes out, I can't drive anymore. Or, the same thing about transmission. Okay, I lose first or second gear. Okay, I might still be able to drive, just not very well. But again, so it kind of looks at what's the ultimate effect on the operation of the area. So, because I didn't want to type all this, and it goes much better explained in the book. The primary goal is to ensure customer safety and production of quality products through these outputs. And this is probably more detail, of what the advantages and of why we want to look at how to be able to use FMEA. Minimize or eliminate design characteristics that contribute to failure. Development of system requirements that reduce the likelihood of failures. So if you can build out, engineer out bad design, and that can also go into the fact of where people might get injured from an accident, confined spaces, falls, things like that. We might be able to reduce that. An example that I give, at least from fall protection, is that most people that have to work on roofs, most parapets are built 36 inches high, right? Well, Cal OSHA requirement for requiring guardrails is 42 inches. So because it's 36 inches, fall protection is required when someone works on a roof, which means they have to harness in, have anchor points. If we just built that parapet 6 inches higher, fall protection is not required anymore. We actually eliminate a hazard where people are going to be working on roofs. So that's an example where you can say, how can we eliminate a failure, or at least it's less likely. Now we comply and we can reduce costs by doing so. And again, talks about we can also apply it to services as well as products and processes. Again, through equipment, used to analyze machinery and equipment design before we purchase. Services, before we release to determine. So it kind of gives some ideas how you can use FMEA in different areas. And it's not just for accident causation. The steps in really looking at it, determine the scope and objectives of what you're trying to look at. Talk about assembling a team, and usually this is a multidisciplinary team that may be looking at the different issue. Define the system components, their functions. For each component, identify potential causes and effects of failure, and then develop responses. So it's just a really systemic process that you go through, and it just takes a lot of time, unfortunately. So it is very time intensive when we look at something like that. But it's really for high, okay, Bay Bridge, something that's really expensive. You want to have, look at where the failure points might be, and then say, okay, we need to make sure that these things don't fail as part of that.
They missed a couple of failures in that one.
Yeah, so obviously, so now we're paying for it because it's now closed indefinitely, at least the new bridges. So FMEA can be followed by criticality analysis. And so in the 4 categories that when we look at criticality, and it talks on the bottom, criticality analysis, it's analysis that identifies the critical components of a system and ranks the severity of losing each component. So category 1, failure resulting in excessive unscheduled maintenance. Okay, well maybe the windshield wiper not being changed once a year. Okay, that might be, that's a very low risk from a criticality standpoint. Category 2, failure resulting in delay or loss of operational availability. Okay, so now we have a car and we're losing, something, trying to think, engine, transmission, something like that. We're going to lose it. It's going to take a week for us to be back operational. Failure resulting in potential mission failure. Okay, us being able to achieve our objectives. Well, there's your, Bay Bridge, and then also you can have potential loss of life. So between the 3 and the 4, those are really the highest categories that we're usually most concerned about. It talks also in the text, a risk priority number. And not so much that they're going to ask you probably how to do this, but it's important to understand, what, again, the concept of what they're trying to get at. How can we help prioritize these risks? And what they look at is you have a consequence ranking that rates the severity of the effect of a failure. So if something happens, what's, on a scale of either 1 to 5 or 1 to 10, depends on how the organization. This needs to be consistent either way. Occurrence rankings rate the likelihood that the failure will occur. So that's almost like probability that the failure occur. And then the detection rankings. So they rate the likelihood that the failure will not be detected before it reaches the customer. So again, do we have processes in place? And when it says customer, you can replace it with something else before it goes into operation, something like that. So on the detection rankings, if we have a process that normally looks for faults, or from a quality control standpoint for our widgets, that every so many widgets are checked, that's where most likely, from detection rate, we're going to detect it hopefully early because we have those. But if we don't have a process, then our risk of not detecting it goes that much higher. So it talks about in here the risk priority number is the product of rankings for consequence, occurrence, and detection used to identify critical failure modes when assessing risk with the design or process. And again, the product of rankings, which means multiply, right? And then the criticality is a combination of the risk priority number elements of consequence and occurrence used to determine relative risk. So it's just saying consequence and occurrence, the first two, whereas the risk priority number involves all 3. Okay, and you'll see an example of that here in a moment. So here's a typical ranking using a scale of 1 to 10. That 1, consequence, no effect, where very high and hazardous, and you can kind of see it just, it's just your normal scale, 10 being, a high risk or fault that we're not going to catch things on these different areas. So again, the example that they give in the textbook is they show here a criticality of 10, occurrence of 10, but detection, we say, it's a high risk area, but so we have really good processes that we're probably going to detect it. So our RPN is 200, but on this one, low consequence but high occurrence, but we don't have any process in place. So our risk priority ranking, our number is now 300. But again, it says while the second RPN is higher, the first will require more immediate attention because it has a consequence of 10 and criticality. So we really want to address those things that are really critical and high occurrence and make sure we have a process. So those are things we want to make sure that we definitely have things in place for when we look at those. And then it goes through and, they give the example of a soda machine not giving change. And you can see criticality is a 6, occurrence is 7, so 6 times 7 is 42. That's your criticality. But then when we do times 9, which is our detection, that we don't even have a method to detect the failure, our RPN goes up to 378. And it just goes through each one of which, what are the concerns that we might have. You're not going to be asked to actually do the calculations, most likely. I mean, that's not part of it. But we may want to, they'll probably give an example and say, okay, which one of these would you want to correct first? And you're going to have something most likely with very high criticality and occurrence, and those are the things from the text you want to make sure you address those elements are the first things, even though it may have a lower number. So kind of like this example that this is the area that you want to be most concerned with. Again, big picture, what are they asking you to do? Understand the concepts when we look at that. Some of the advantages, disadvantages, widely applicable to many different systems when used in the early design, improve quality, reliability, and again, it talks about emphasis problem prevention by identifying problems early. That's really the idea by FMEA. The downside, it's a top-down tool. May only identify major failure modes in a system. I mean, how deep can you get into the different elements of that? There might be other methods, and fault tree analysis can help with that as well. And again, what I mentioned earlier, analyzing complex multi-layered systems can be difficult and tedious, and time-consuming and costly. It can just take a lot of time to do those. Usually advantages, disadvantages, which ones would you use? Those are the type of questions you're going to see on the exam to know which is the better way to go with these. So, make sure time-wise. So now, fault tree analysis. So fault tree analysis, as I kind of talked about earlier, is kind of the opposite of FMEA, where you want to start from. It's analysis that takes a particular system failure and traces the events leading to the system failure backwards in time. So the idea is, an example they give is, someone has an injury to their hand. Well, what could lead to the injury in the hand as they're doing this type of function? Or the potential is someone could fall. Well, what could lead to that fall? People not wearing fall protection, things like that. Use the deductive method of moving from the general to specific. Again, using, okay, someone falls, now let's find out what can happen. To examine conditions that led to or influence a risk event. The idea is finding ways to break the fault tree by interrupting the sequence of events leading to a system failure. You probably saw the things about, and or gates, which describe a relationship. And I think this will be a pretty good example here. So the first one is injury to the operator. And right up here and down at the bottom it says here's what an AND gate looks like. So this is an AND gate. So in order for the injury to occur, the ram has to be descending, the operator's hand has to be in there, the press has to be operating, and the die is not guarded. So all these things have to be happening in order for that event to occur. So that's the AND. AND gate means that all events have to occur within an AND gate for the injury to happen. So if any one of these things does not occur, there's no injury. Now, these are all OR. So how could the press ram descend? Well, it could be the clutch was tripped by the operator that would make that happen, or had failed. The part had broken, or the clutch could be worn out, which could have led to a failure. So the idea is it could be any one of these things that could lead to that. So you can kind of see when you look at, from a fault tree analysis, how do you break the cycle? As long as we have good maintenance on this, then we can pretty much eliminate the ram descending. Well, if the die is not guarded, well, with a defective guard, it could be that, or the person could have removed the guard, or there just was no guard at all when it was first installed. And again, OR gate means that any one event is sufficient to cause that specific event to occur. So you most likely will have a problem where you have to do a little probability analysis. We did a little bit of that, I think, in 54. So the idea here is that whenever you do, what's the probability of S and T and U happening? Okay, so the probability of, I don't know if they give the definitions of S, T, and U, but anyways, the hand, it's different elements of the press operation. So the probability of S is 0.15, of T is 0.2, and U is 0.3. Whenever you have an AND event, you multiply. So AND means multiply, OR means typically you're going to add. So because all these things have to occur, and if you think of this logically, and again, I'd even, if the picture's not there, draw a picture, that the probability of all those events happening at the same time is probably going to be pretty small. So that number, the probability, should also be pretty small. In this case, it's 0.009 is what, so multiply by 100, and you're going to go up with, 9%? 0.9% would be the probability of this event actually occurring based upon that. Now, they also give another example of when you have an OR gate. And this is why you're going to have most likely a question on this, because it's one of those tricky things. It says the probability H or I or both. So we have the probability of H is 0.4, the probability I is 0.2, and now you see they say minus. Okay. Now if you just did, if you added these together, you come with 0.6, and you say, okay, that's probably, But the problem is that the reason why you have to subtract out is because this is the probability. This is where they cross over. You're double counting. If you and so that's why I include. That's why I always draw stuff. Is from a Venn diagram, we consider this is the point. This right here is 0.08. So we need to subtract out the probability of them both happening because we already counted for it once here and once here, and this is the crossover. And that crossover is an and, so that's a multiply. So hopefully that makes sense. But most likely, in my past experience on fault tree analysis, there's a question that deals with what's the probability with an and or event, and they'll give you the numbers, and they're going to have now most likely there's going to be an answer that's going to be 1.2. Okay, 1.2 cannot be the answer because probability cannot be greater than 1. It's probabilities always has to be less than 1. So when you see an answer that's 1 and higher, you can cross it off. That's not going to be the answer. But I can almost guarantee you there's going to be an answer that's going to be above that. The 5 steps, again, oh my gosh, 5 steps, it's listed, right? Fault tree analysis, identify a specific harmful event to construct the fault tree, be specific as possible. 2, diagram and reverse order the events. 3, determine the events leading to any other event, connected by and or gate. Evaluate the fault tree during possible system improvement and make suggestions. So those are the 5 steps. Again, most likely that's something you want to highlight. Again, assumptions and limitations. Again, the way, when you look at it, if all components exist in only 1 or 2 conditions, success or failure. It either works or it doesn't work, right? Any system component's failure is independent of another component's failure when you do this. And each failure has an unchanging probability of occurrence. And so, again, from the assumptions, these are the things, again, at a 50,000 foot level, what's important to keep in mind if you're using fault tree, here's some of the considerations as part of the assumptions you need to be aware of. The limitations, as part of that, a high degree of certainty does not exist concerning probabilities of underlying or base events. How do we really know the probability? These are really estimates in many cases because we may not have past experience with it. Important pathways to the top event might not be explored if all causal events are not included in the fault tree. I mean, how many things can you include? I mean, how big is you're going to have, a whole board full of things up there. Fault tree is static, human error is difficult to characterize, and then you have the domino effects of conditional failures that may not be easily included when you start looking through it. All right, making good time here. So the 5 whys, we talked again a lot of these things last week as well, but we go a little more detail. So one of the elements, the reason why they go into this, and they talk about the fishbone diagram, I'd say most people probably do the 5 whys without the fishbone, but and that's one of the things the reason why they include it is because it's essential to do the fishbone. But again, which one of these is used for which method? Used primarily for problems involving human factors. Again, most likely that's where a question, 50,000 foot level question, right? Primarily for problems involving human factors. Helps prevent investigators from relying on potentially erroneous assumptions about the root cause of the problem, and really tries to trace a problem through chain of causality to its origin. The steps, the 5 whys steps, of course there's only 4 steps to the 5 whys. The specific problem under investigation is described completely, formalize what the problem is. The investigator asks why that particular problem occurred and determines the answer. If the answer does not reveal the problem's root cause, the investigator determines why the problem is embodied by the determination made in step 2. And you keep on asking the question until you feel like you've gotten to the point. You just keep on repeat the previous 2 steps in there. So fairly simple situation. Injury to press operator, why? Press ram descended, why? Clutch was failed, why? It was worn out. And you just go through and you get down to because the final answer, because management policy did not require clutch inspections. So it goes back to when I talk about operations or systems, you might want to say, well, it's because of the maintenance issue. Well, no. Well, there's no process to ensure that we would even look at that. And so now we say, okay, we know in the future that this is a possibility of failure. It's a critical component that can lead to an injury. So therefore, we need to do a preventive maintenance schedule after so many hours that we're going to include that now as part of that. Obviously the advantages, helps determine the root cause. When you can find several root causes as part of the process, it doesn't require statistical analysis or data collection. It's fairly easy. Anyone can do it. Doesn't take a lot of training. Just ask why, and kind of just ask those questions. Again, disadvantages. Sometimes people may just stop after the first, thing. Okay, no, I think we got it. They don't keep on digging. It might be just seem that too easy to do that. Tend to focus only on one answer to each question. There might be multiple answers to that why, and so that means you got to branch off when you do that. It says organizations sometimes help the investigator ask the right why questions. I'm not sure what they mean by that, to be honest with you. An uninformed investigator cannot ask relevant questions, so they got to understand the operations to know, what they should be looking for. And depending on who the investigator is, they might actually get different answers as part of that process. So here's the fishbone diagram. And so what they basically say is when you go through as part of the why, you have the problem being investigated, and then you'll start outlining, methods, machinery, manpower, materials. And in there they talk about like the 4 M's and the 5 P's and all those things, because those are the typical things you may want to look at. And so it goes a little more detail. They're not going to, it's a multiple choice. You're not going to have to do a fishbone on the exam. But what they will be asking is, okay, how would it be used, what the processes are. So don't get so ingrained in, oh my gosh, I need to know how to do a fishbone, because you just want to know the methods of how you'd want to go about it. So these are the steps. I'm not going to go through all the different steps, but the idea of the fishbone is you're also getting a team involved. So whereas the first one with the 5 whys might be investigator, now you're going to do more of a team facility. You have a facilitator. You talk about the categories. Team members brainstorm a possible specific cause of the problem using techniques such as the 5 why, and they write specific cause for each branch, and they just go down through the elements here. And the example that they provide is gas mileage does not meet estimates. And so the methods might be using too low a gear. So these are the methods of someone, of how they're driving the car. So these are problems with how person, again, the 4 M's on here. Because the methods, they can't hear the engine, and maybe because they're playing the radio too loud that they can't hear the engine, which makes them use too low of a gear. Or speeding, and you kind of go through machinery under inflated tires. So the area is leaking air stems, and again, poor design that leads to leaking air stems, no procedure to check tires. And again, just kind of walks through all the different elements when we do the fishbone. So we went through chapter 3, excuse me, 2 pretty quickly there. Any questions before we move on to the next area? All right. So I think we'll be on time here. So chapter 3, we're going to go into business continuity management. And when we think about business continuity, I think it's become much more prevalent because of the natural disasters that we've had in the last 10 years, really. Most recently, Superstorm Sandy, that has an effect. The hurricanes. I mean, there's just been so many natural disasters. And then also, I would say, because in many ways, I would almost say was that Y2K was really the first, from a tech standpoint, that all of a sudden everyone got all scared because of technology, that we depended upon it so much that everything was going to crash. And so then all of a sudden, people thought about all the systems in place. And then that almost became the big event where people really started looking at the operational side of the house of how can we prevent that. So we've always probably had the natural disaster, emergency management aspect. Y2K probably brought the technology aspect into it a little bit. And then most recently we've had, avian flu, H1N1. We had the pandemic type of issues where, well, what if people get sick to where they can't come to work? How do we continue to operate? How do we function as a society where people can't be in a room together? So those are some of the things that we now see, and you'll see some of the examples of that as we talk about it more. On the educational objectives for this chapter, one of the things that we want to be able to describe the evolution of business continuity management. It's in alignment with risk management. So that's, again, the history of how do we get to where we are now, where we really talk about disaster preparedness and, helping people recover after that, to where now it's really part of risk management. It's aligned much more. Explain how risk mitigation is achieved through business continuity planning. Describe the scope and stages of strategic risk redeployment planning. And I think that's good examples with BP. We'll talk about some of that. How supply chain risk management is used to assess the flow of goods. Risk mitigation is achieved through efficient communication, and also we'll do a scenario on supply chain and talk a little bit more about some of that here. So when we talk about continuity management, really what we're looking to address the threats to operations, which can be natural disasters, major physical damage to a building, loss of a critical supplier, or pandemic outbreaks like I just mentioned. So loss of a critical supplier from a continuity management. Think about, even though it wasn't our natural disaster that affected us, but if you are an auto parts or auto dealership in Fukushima, well, most of the parts from Japan, all those things, that had an effect on the supply chain in the U.S. to be able to get certain parts. So those type of things of where do you get your supplies from? If we have, continuity management from a standpoint of oil, that's, it's also, besides being a strategic issue, it's also, well, gas prices go up. How does that have an effect on just all operations? It's somewhat political, but it's also affects the operations, whether it be airlines, those type of things to keep track of. So part of continuity management involves examining threats and establishing operational plan with contingencies for key operations and critical functions to continue. And the idea, again, is critical functions to continue. The whole element, the goal of business continuity management, and from a risk management perspective, is survival. If you have a major disaster, whether it be a natural disaster or something like that, at the end of the day, your number one goal, they used to, in the old textbook, they actually talked about the pre-loss goals and post-loss goals. Well, your main goal is survival. Your goal is not profits at that point. It's not all those other things. The main goal is you want to survive as an organization. And so whether it's having insurance, all those different things, because if those things aren't in place, you're not, you may not be around. And again, seeks to minimize loss of resources essential to a recovery through pre- and post-loss action. So there's certain things that, when we talk about business continuity, that you can do before preparation, having contingency plans, having duplicate, areas. But then after the disaster occurs, what are you going to do after the fact? So you can have different actions after the disaster occurs, and that's what it talks about. It's, there's things you can do before and after that will help. The evolution of business continuity management. And again, they use BCM, BCP, all these things. I'm not used to that. I don't think most people are used to, at least, maybe some of the emergency management folks are used to using those terms. But if they use it in here and they do BCM, they're probably going to use it there, and they may not say business continuity management. It just, once they start using acronyms, just be aware of that. Again, originally started as emergency preparedness and response planning, and the focus is really providing supplies. When you think about emergency management, 15, 20 years ago, it's like, okay, we need to get water and food and shelter, and that was really the whole, and train personnel to help out. There wasn't a whole lot, okay, besides boarding up windows and maybe sandbags, there probably wasn't as much thought of, okay, well, where are all the records kept? Where's the hard drive? Where's our backup facilities? I mean, now we think about those things much more, where we didn't have to think about those before. And the disaster recovery planning, again, emergency preparedness was just really to respond. Disaster recovery is, okay, how are we going to get back things in operation? It really grew to the increasing use and dependence on technology. So then we started, and IT led the way of data management, storage, communications, looking at critical systems. IT departments, they were ahead in developing plans to protect data. How are we going to get things up and running again? Where are the data management systems located? Is it in the basement where the water will go first? Those type of things. And then really the concept of business continuity management grew out of realization that organizations had to look beyond their organization to other systems. So all of a sudden we started looking at, okay, yeah, we're just concerned about ourselves. And then we thought, oh, you mean if, okay, I'm a retail store and I have clothing made in Bangladesh, that should I be concerned about what's going on there? And now you have some of that concern where they're now there's obviously increased pressure on other countries to bring up their safety standards because it has a reputational risk, a product being, there's a whole bunch of aspects that go along with it to where customers are putting pressure on that. And so we deal now with supply chain disruptions and to really look at those. So example, Superstorm Sandy was a really good example of a lot of this. So most people don't realize, besides, obviously, I went to a conference and the New York Metro did a presentation that showed the water that was actually in the subway system. And literally it was, they had to pump out the water. There was no expectation that, it was never obviously intended to be there. But all of the cabling that they're going to have to replace, all the wiring, the damage that salt water does to all the metal might be survived now for a little bit, but they're going to have to replace the whole infrastructure is basically shot. And so from a transportation standpoint, how long, now that they've got it, what are they going to do to prevent it? They're talking about, the seawalls and other things, but how can they look at those operations? From a research standpoint, for universities, we've talked to several where they've given examples. A lot of the research was in basements. They had, when I talk about research, there might have been animals, 20 years of research, basically, cancer research, those type of things, where they didn't have, in some cases, weren't able to get the animals out. And so what that's brought up is how do we, not only for different types of research, but how do we make sure that when we hear warnings, how else can we get that, whether it be the material, the knowledge, the paperwork, to make sure that that's not there. And again, communications, transportation, all those different things certainly have an impact when we think about Superstorm Sandy. Then we talked about aligning business continuity management with risk management. And when we think of business continuity, it's really about operational risk. It's how do we keep the operations going, be functional. But when we think about risk management, we're talking not only operational, thinking reputational, hazard, financial, strategic, all those aspects. So really, there's a nice alignment with business continuity that really fits into risk management. And I would say in many ways, not that emergency management and business continuity didn't get the respect that it probably should have, but it made people realize of the real financial impact that this really is part of something people should consider. Because a lot of times people go, no, we won't invest how much money for something that may never occur. But when it's under risk management, there's the probability, there's more, it kind of gives it a little more leverage than it may have had in the past. And also, functions may be housed in different departments. And when we talk about the functions, talking about risk management and business continuity, they may be in different departments, but they really need to be coordinated. Again, from a risk manager's perspective, you don't want to be siloed, these different things. Well, no, they're doing that and we're doing our thing. And at least for the UC, we have emergency management actually does fall under our operations. So there are some certifications and standards that they talk about that you're seeing more. There's the British standard, organizational resilience talks about that. But the one I'm going to mention is NFPA, National Fire Protection 1600. So NFPA 1600 is a standard on disaster, emergency management, and business continuity programs. And it's a volunteer standard, but the idea is if you're doing some of these things, you should be better protected. And it's more of a management systems approach. And so for those that have the slides, you should hopefully be able to see this. But what we actually do is we measure all of our campuses. They actually have to do an annual assessment of their compliance with NFPA 1600 and where they're at with, 3 being that they're green, yellow, they're almost there. If they're red, they're not. Obviously, or orange, they're in the process. So compliance with laws and regulations, so joint commission requirements or policies, or how are they with their policies, continuity recovery plans, that they have the plans there, crisis communications and public information, ability to respond to information requests, establish emergency public information capability. So it goes through, and we actually ask each campus, and they do this annually. So our goal is we want to be all green. And the only way you're going to do that is by greatly doing this.
Yes. Is that what each column represents there? Is one of the campuses?
So yeah. That's why I hit the columns. So, but yeah, it represents the campuses. Now, the other thing that I think I showed, so this is one aspect. We actually ask our emergency managers to do this and say, and this goes to our senior leadership so they know where their campus is at. Because if you're in a lot of, non-green, then you're probably concerned. And we need to step some of those things up to make sure that there's employee assistance, financial administration support, things like that goes with it. So on the 7 steps for developing and implementing a business continuity plan, we're going to go through each one of these a little more in detail, but again, 7 steps. Most likely you're probably going to want to know what the 7 steps are. Understand the business, which seems obvious. Conduct business impact analysis, perform the risk assessment, develop the continuity plan, implement the continuity plan, build a business continuity plan culture, and maintain and update the plan. Now, when we talk about business, a lot of times, again, business continuity, it's really can be business of the charity, the agency. It doesn't really. I mean, business. A lot of times people go, well, we're not a for-profit, so it doesn't affect us. No, you want to have a continuity plan. Just take out the word business if you need to. But the whole idea is it all ties back into mission, vision, and strategy of the enterprise of how it's going to achieve those. So it doesn't have to be natural disasters. It's those things that are going to impede and may disrupt its operation. And again, the whole idea is survival. So when we talk about understand the business, so understand that what are the key objectives of the business? What are we trying to do? How it uses the facilities, material supply chain, human resources. There's a longer list that's in there. Technology, to understand how these different things function within an organization. If you're small mom and pop, it's not going to be as big of an issue. But obviously, for for a university or a large city, or even small city, there's a lot of things of what's the objectives that could be impacted. And the idea is allows for identification of key processes that constitute basis for business impact analysis, which is really the next step. So on the business impact, we say, okay, once we understand what our business operations are, we know what we do, assess what events may occur, when they will occur, and how they could affect achievement of key objectives. And so we've actually done, this is where we talked about a risk registry last class. So they kind of tie in together when you start thinking about business continuity and risk management. They really do tie in. You can think of natural disasters. We can think of, okay, power failure. Okay, what's a major power failure? If we started, and maybe do we have backup generators will be part of the continuity plan. Avian flu. Okay, impact. Well, how many weeks ago did we have a BART strike in the Bay Area? Well, how does that impact operations? What's our plan? Do we have, and so we, if we can, we have people work from home. We tell people not to come in. I mean, so those type of things. Or when we had Occupy protests, all those things start becoming, and maybe there's not plans specific to those events, but those are the type of things we start thinking about of how can we, what are we going to do in those situations, or similar situations to have that. Distinguish critical versus non-critical processes. Do we have to have people here to, well, again, if we had a failure, well, payroll is important, right? So if we had a failure to where we couldn't produce payroll, what's our backup system? So I know that from being involved in the process, we do have backup systems to make sure people get their paychecks. In the event that this building was shut down, we could still do that. And we have automatic processes with agreements with the bank that they will automatically issue checks to employees to get them out for us. And then for ISO 31000-2009, which is the risk management standard, international standard, business continuity and risk assessment, they're combined. It's part of they're really tied in as part of a singular process with that. The next step after that is performing the risk assessment. So we identify the risk register of all these possible events that may occur and the probability of those. Then we identify and evaluate the potential exposures to the probability that certain events will occur. And then when doing that, it's going to help us prioritize and make decisions regarding organizational appetite. Are we willing to let something fail? There's certain things we say, it's non-critical. Okay, if it happens, we need to focus on these, payroll is more important than these other aspects of the operations. to make that happen. And part of the process when doing the risk assessment, hopefully it'll reveal exposures and assist in establishing methods for future mitigation efforts, and also help develop the action plan of really what the next steps are in here. And you kind of realize these things take time and resource for people to just sit down and think about these things, but you figure what the cost is if you don't are going to be so much greater without the proper planning. So for those that are part of UC, or those obviously that aren't, we actually have developed a, over in the, well, right, it says UC Ready Planning Tool. This was actually developed by UC Berkeley several years ago, and it is used to be called, what was it called? UC, was before UC Ready, it was, Berkeley had a different name for it. But anyways, but what this actually does, this tool helps prepare business plans to the department level. So the idea is the department will enter information about what their operations are, what their key functions, and will actually help them develop a business continuity plan that can be then printed out, as well as held to say, okay, if something happens, they'll start, it walks them through the process to start thinking of, ooh, I need to back up this, and I'm going to need to do this, and especially for researchers, we're really encouraging. We actually have UC Resiliency, which is more for the researcher side, whereas the UC Ready is more for administration side. And again, it kind of just walks people through the processes to really think about, based upon these different events that may be more likely to occur, what are the steps in doing that. And so, anyways, that's something that, and we also track completion of all those to make sure we know how many departments have completed them, and so that's part of the senior leadership's measurements on, you know, how many of these are done, and we can track by department, by division, all those things of how we've done on those.
Yeah. It's kind of a random question, but do you actually run some degree of risk if you're doing this BCP planning? You identify vulnerabilities that could really affect your operations, but then maybe you don't have the resources to address them?
So the question is that if you identify these things and you don't do anything to address them because you don't have the resources, and I would use actually one of our trainings, kind of the not quite the same thing, but kind of the ostrich defense. The idea is that if you're just ignorant of it, of something, do we really want to know? Right. Some of these, it's just kind of what it is. And really what it comes down to is that it goes back to the risk appetite, is that we can raise all the issues. So in an organization, you can say, here's all these things. If we don't do this and something happens, here's the potential results. And are you okay with that? Or do you say we buy, maybe you can't put in the specific fixes, and then your post-loss action is going to be you buy more insurance, which costs money, but that doesn't really prevent, it'll still impact your operations possibly, and that's why you look at the criticality of saying, look, we have to do these things. And if senior leadership knows that, then, and they make the decision not to, then that's on them. I mean, that's what they're getting paid the big bucks for. Right. I mean, the emergency management team, as you go through these things, the whole idea is identify those things that could really have an impact. But most of the time, people doing that may not have the authority to say, we need to spend $1 million or whatever it is to do some of that. But so that, yeah, that is part of the whole thing. That, and maybe there's not, you're prioritizing. We got to get this one on first, and it's like capital budget. In the next year, we're going to do this. And actually, a good example on deferred maintenance was earthquake refurbishment on some of the campuses, earthquake bracing. So that became, in the Bay Area, that's a higher priority than it might be in Merced, right? So that's going to get more expenditure to make sure that our buildings have the right, because if those buildings go down, what's the cost of that versus putting the bracing up? And so a lot of our campuses, they've done a lot of that retrofitting over the last several years. And actually, if you think about it, the whole reason why the new Bay Bridge was built was for earthquake and retrofitting and bracing and all that. And look where we're at with that. Anyways, that's a whole other story. Okay. So as far as developing the continuity plan, there's a couple different ways that once you identify what the risks are, and talked about, conducted the business interruption, you may use one of the strategies or combination of strategies to ensure resiliency. And a lot of times, resiliency is really used more in Europe, or, Britain, you hear resiliency used a lot more, but I think it's becoming more of a common term when we talk about being resilient in our operations. And so the different models, they talk about our active backup model, establishes a second site that includes all the necessary production equipment housed at the primary site. Staff may be relocated to the second site if operations are disrupted at the primary site. So, for our technology, for example, and a lot of times you want to keep those far away from each other because you don't want it down the street, your backup site. A lot of times, most people that use backup for technology, it's actually someplace in the Sierras that no one knows where it's at, and it's like fortified structure where people have all their technology, their data is being backed up there because there's less risk of earthquakes and all these other things. They have all these backup generators, and so that's what they're getting paid for. Split operation model, and I maintain 2 or more active sites that are geographically dispersed. Capacity site is sufficient to handle total output in the event of disruption at one site. So if you, again, not just technology, you think about distribution center. Distribution center catches on fire, or something happens, you have another facility that can still work in its split operations. Alternative site maintains production at active backup site that functions as the primary site as needed. And then contingency model. Strategy involves organizations developing an alternative way to maintain production, perhaps using manual processes, things like that. I know, example, when I worked for Raley's, they had the distribution center. In the event of refrigeration failure, which would be the biggest, obviously that would be a huge impact. They had agreements in place with another warehouse facility that automatically they get first priority. Our UC also has agreements in place that if for diesel, for the backup, for the generators, that we have agreements that we're first in line. A lot of our cities, municipalities have those that, hey, before anyone else gets all this, we have guarantees of X amount of gallons of fuel as part of that. Now, again, if there's roads are closed and can't get to you, that's a whole other story, but that's part of it. Also, we developed a continuity plan. Again, there's strategic choices for addressing a disruption of operations. So mentioned, okay, you can have an insurance policy. Allows the organization to recover some of its financial losses from an insurable. Doesn't necessarily help with operations, but you'll be able to recover dollars, and maybe that can help you start the business over again. Transfer processing, reciprocal arrangements with another company or division to perform necessary function in the event of disruption. Okay, that's what Raley's did with the warehousing. They had more of a transfer process. Termination, they decide, okay, we're not going to do this anymore. Okay, trying to think, there's some, they may have this type of service they provide, it's gone, we're not going to restart it, we're not going to continue that type of service. And I was thinking of the example, I know there's an example I'll probably think of later, where people said, okay, we had a loss and we're just going to shut down.
Amtrak did that after Hurricane Katrina.
Okay, no more service?
Between New Orleans and Florida, that service no longer exists.
Oh, wow, okay. So, yeah, perfect example then. Because of the risk and, having to do all the costs of redoing the rails or whatever, and it just wasn't worth it. So, yeah, there's a great example. Loss mitigation entails implementation of risk controls and plans to reduce or minimize the loss. A lot of times that's almost always going to be put in place. Or you just do nothing. Absorbs the potential loss, and in which it talks about this represents an increase in risk appetite that you decide, you're not going to do an insurance policy, you're just going to kind of like what you mentioned, well, most of the time you're going to try to do something. Maybe you can't do everything you wanted on that list. You identify these. But the idea is if you do nothing, then there has to be recognition that you increase the risk appetite to take on a lot more by doing so. It's a decision by not making a decision, essentially, in some cases. Again, when you implement, talks about, which I think goes right back to the UC Ready, each department's plan must include these elements. So it actually goes down. It's not just you can have a plan for the organization, but it's really important that every different department or different operations have a plan, because what they do might be unique, and so they need to make sure that they've thought about those considerations. You can't say we're just going to have one plan and it's going to work for everyone. And statement of acceptable level of function and running. Is it enough just to have computers and internet access? Do we need to have lights? Can we run virtually? Can we say, okay, people can work from home until we have the building back up and running? Recovery time objectives, resources needed, potential failure points, should address tasks and activities required, supporting documentation information, structure to support the plan. Again, if you say you're going to have internet, do we, as being the means and people working from virtually, do we actually have a central phone line? Do we have, how are people going to, the VPN or whatever access, how are they going to get into the network? Do we have those structures set up for the amount of people that may need to access them? Description of division teams, interdependencies with other divisions, what we may do affects another department. All those things have to be considered as part of that. We do have a question. So FedEx, okay, another person wrote in, FedEx abandoned a satellite-based rapid document delivery system after the Challenger disaster. The satellite was on Challenger. So based on, yeah, that's I had no idea on that one. So yeah, based upon the cost and everything, was it worth them for them to go in there? It'd be interesting whether they bought insurance for something like that. Because obviously that's a high-risk event, whether you do something like that. So we talked about building a culture. How do you do that? Kind of the brief paragraph, but here are the nuggets that at least I thought were important. Senior management must provide support for the business continuity plan. One of the big ways that most organizations do it is through desktop exercises or hypothetical disaster scenarios, because ultimately they're going to have to make decisions. A lot of times the decisions you might have, we have two structures at least within our operations. We have more of the operational aspect than we have the strategic. Well, that's the senior leadership needs to make those strategic decisions of how we're going to handle the reputational or crisis management aspects. But they need to be part of that. And when they do that, what happens is they understand the holes. When you do those scenarios, those drills, they can figure out where the gaps are. And at least my experience has been that's really been eye-opening when you realize, okay, wow, we've got some huge holes that we need to fix over here. If this scenario really happened, we'd be in trouble. And also, I think it's when we talk about crisis communications, really the importance of crisis communications even becomes more key. And then the different suppliers, customers we should know about when we do our business continuity plans, risk management facilities. You can think of all these things that are really part of that senior leadership, kind of the different silos a lot of times that might be out there that really need to be brought together. And then the last piece of it is maintaining and updating the plan. It's only effective if it's fresh and updated. In the book they talk about semi-annually being updated. And when they talk about updated, I don't think it's the whole plan, but I can tell you I know that when management changes, all that, the plan's updated with who the key personnel are, who's going to be. So it's probably true that it's probably really updated on semi-annually, even though it seems like a lot very often, but it can be just the updates of the personnel and make sure that those people are trained on what the expectations are and what the processes are. And then also where to store the continuity plan. How are you going to access it? I have a binder. Well, what about having it on SharePoint or thumb drive or my laptop or an iPhone? Those are the things that people need phone numbers to access. We actually have little cards made that, business cards type thing that say, here's the key number that we can call into to access those things. So now we go into strategic redeployment planning. And this is obviously related, but a little bit different as far as that. So the question just asked is all this considered enterprise risk management? And yeah, in the context, when we think about enterprise risk management, ERM is anything that it's a risk to the organization achieving its objectives. So in the broad sense, everything that we really do, whether it be operational or strategic, it really is enterprise risk management. It's all these things are combined, and the idea of traditional risk management is really just focused on the hazards. ERM is concerned about the reputation, operations, all those aspects. So absolutely, I would consider this really part of ERM in the broad sense of the term. So strategic redeployment planning. So this is the key word is strategic. So this is really the executive aspect of how we're going to get back in our operations. And it really helps determine how to resume business operations and ensure survival and recovery. And the reason why it's called strategic redeployment is that when we have a disaster, how are we going to, we might have to realign our strategy of how we're going to do marketing, how we're going to redeploy our assets, and it goes into the crisis management. And the thing I have on there, decisions that are made are not just operational. They may be strategic. How are we going to address, because of a certain situation? If you think about from a crisis management, Occupy protest, or we had, at Davis, we had the situation from a strategic standpoint. UC is now retraining, doing civil disobedience training with senior leadership of how to handle this. Police are getting retrained on this aspect. So it was a huge strategic decision, investment of dollars and other aspects, to, because it certainly has an impact, and it may not affect all the operations, but it certainly has an impact of what we do on a daily basis. And when we think about that, it's determine how to realign to survive, regain position in the marketplace, or protect its reputation. And we'll use BP as an example here in a little bit as we go through this. So some of the different stages for a comprehensive plan for resiliency after severe disruption. Then we want to get it back into the process. They're designed to bring organization back from a state of chaos in 4 stages. And we'll talk more about specifically the emergency stage, alternate marketing stage, contingency stage, and the communication stage. Again, those are the 4. Hey, it's a list 4, most likely, probably questioning on how you bring back, and again, from chaos in 4 stages. The idea is that there's something going on that we need, it's out of, we talk about chaos, it's somewhat out of our control. How do we regain control of whether it be the message or what we're trying to do as an organization? So the emergency stage, fairly simple, 3 objectives: protect people, protect physical assets, and protect the reputation. Are the 3 primary objectives when we're in the emergency stage. Obviously, primarily the people, we need to do that. Physical assets, buildings, those type of things. The reputation, again, we'll kind of talk about this, it aligns a little bit with communication. Some of these things are occurring at the same time when we talk about the stages, so it's not 4 distinct stages, as you'll see. The alternate marketing stage, which is where we want to evaluate the impact of disruption on the organization's reputation and market share. So, okay, so again, we'll use BP now. So, Deepwater Horizons, we have the explosion. First, hopefully protect people, those physical, and then the other part is reputation. Well, what do we know about the chief executive officer right afterwards? Wasn't he playing golf? We saw a different, he's on the boat. That's right. He was on a yacht afterwards. So from a reputation standpoint, it looked like he didn't care. So alternative marketing strategy, that's part of, again, the communication is protecting the reputation. Might be the messaging that goes with it when we get to the communication stage. But a need for new marketing strategy. Okay, if you look at BP, it took them a little time, but what's their marketing strategy now? We're cleaning up, we're revitalized. Okay, this is their alternative marketing stage where they're still in it. When you think about it, customer loyalty considerations, that might be part of how they're doing it. Issues with suppliers and subcontractors. What about competition? Continuation of product lines. Are they still doing deep water drilling? Are they doing more shore? What type of thing? Does it affect their strategy? They're focusing more on, hey, look, this is what we're doing for clean energy. They're trying to change that image when you see those type of commercials that are out there. Contingency production stage, determination of what products and services will provide based upon facilities, technology, machinery. So this is in the event that because of the operations we can't continue, maybe, in their case, they still had other operations they could do, but they would have to, if it's a different type of operation, if you're a warehouse facility that something happened, or crisis, maybe the roads are closed and Highway 50, what's your contingency? Well, now we need to go to Highway 80, maybe it's a longer delivery time. That might be part of it, but you have to consider the supply chain. Or let's consider that we got our parts from one supplier, they went out of business, something happened. Now we have an opportunity, our contingencies, well, we have to go to China or Bangladesh or something, and now we have a cost and quality issue. Or now the transportation to get the product to market might be more costly, something like that. So those are part of the considerations. On the communications stage, The sole objective is to preserve or enhance stakeholder trust and confidence in the organization. And this is where we talk about crisis communications. And it really begins, it talks about when the disruption occurs. And when we go to actually the other chapter, they talk about more specifically, they says even before the crisis occurs is really when you do crisis communication. And ends with when production and reputation has been restored. So pretty much in crisis communication mode, technically, the way the book defines it, when production and reputation is destroyed. They're still doing, again, the alternative when you look at BP. Then 4 basic internal external concerns that need to be addressed: safety and security of all stakeholders, transparency in all this management decisions, clarity and consistency in communications, perceived lack of trust in management and organization. And again, I'm going to talk about good relationship with news media is essential, and regular communication with employees. I'll give an example. Part of this, you contrast, Southwest with the nose gear issue. Okay, Southwest, I think, when you look at transparent, most people perceive it as a good company. Flying it the other day, it's one of the few where you see, from an objective, I think they really practice ERM. It's the only airline where you'll find the pilots, after they land, actually helping pick up the trash in the cabin because to get the turn to go there. Their commercials, the things they support, all those things, they're very visible in their regular communications and all the things that they do. Where, so if you had, obviously you had I don't know if it's a minor issue, but you had a situation, but the scrutiny on Southwest for a nose gear failure, do I still have faith in the company? Do I have faith in their maintenance? Do I have faith? Do I trust? Because they built up that trust over this period of time. Their communications has been there this whole time. So when they need to use that kind of trust bank, that I'm okay. If it's, BP or maybe oil companies in general, or maybe it's another airline where because the way, well, even with Southwest, they don't, the whole image of no baggage fees, all this. But then when you fly United Air, or these other airlines, if you have an issue, it looks like they're cutting corners. The perception may be, I'm just throwing this out there, that they're so nickel and diming or these other things, the customer service level may not be there. It's like, if the same thing happened, would I call into question the maintenance? Would I call into question? So I'm not disparaging any of this, but I'm just trying to point out that your perception of an organization is being made up by all the commercials that have nothing to do, about what they do on a daily basis. But because they presented this image of trust, when something does bad happen, it doesn't make the press coverage, whereas the news media might be all over a different organization because they're not as transparent or clear. So the untrustworthy at this point are probably banking industry more. I mean, so when you think about it, because they're tarnished. If you look at also the cruise industry, okay, Carnival, they've had 3 or 4, I think maybe 5 now, incidents with their, so when something happens now, it makes national news, whereas before, these things have happened before with other, and they don't get the press attention, but now they have because it's on the radar screen with them. So anyways, just hopefully it brings it into context when we think about that, the whole strategic redeployment aspect. That's kind of what we're talking about. It's kind of like that political capital aspect in there. Another person said an example is San Onofre nuclear generating station. So yeah, I mean, people don't trust what's coming out of the information that, oh no, it's just a minor thing, and now, I mean, they're still shut down. Now they're going to shut down for good. But those type of things make you call into question the transparency of the organization. Are they really telling the truth about what's going on? Okay, so we get not too much far over here. Supply chain risk management. Now, we talk about supply chain, it involves assessing and mitigating all the threats that might interrupt the normal flow of goods and services from and onto an organization's stakeholders. It could encompass volatility related to producing, transporting, as well as storing goods. So, how we're going to access those materials, all those things are part of the supply chain. The other thing is that some more organizations have gone to just-in-time, merchandising or just-in-time supply, Walmart, others, because the idea is the more you handle it, the more you store it, well, there's more cost. So if you go just-in-time, the downside to just-in-time is if you have a supply chain issue, it's going to affect the product in your store, whether you can sell the product or not when you go to just-in-time. I'm not on the threats and opportunities. It goes to product location, production location, because they're vulnerable to natural disaster. These are the things that a risk manager would have to keep in mind, or I would say leadership, if they're going to buy a new facility. What do they need to consider as part of the risks with their operations when it comes to supply chain? Production bottlenecks, infrastructure, strikes, okay, all those things can have, or machinery breakdown can be part of that. External exposures, and this is a long list that sole source suppliers. If you only, an example they'll give is we have a sole source supplier, an example. Disruption in supply when only one supplier of goods is available and they have to shut down, then what does that do to your operations? Geographical environment, might be political issues, taxation, things like that. Again, from a broad sense, not that you need to know all the specifics, but you want to think about, what are the, most likely you should be able to think about a supply chain. What are the concerns you might have if you were an organization and you had to operate there? Organizations also assess supply chains to uncover potential opportunities that may include, inventory storage costs can be reduced by using supply chain for just-in-time deliveries, improvements in technology, supplier relationships can be improved to build positive relationships, so you can look at the upside of the risk as well. But the idea is you need to balance between efficiency and vulnerability to disruptions. There's trade-offs. You might get some reduced cost to these other areas, but now you're also jeopardizing because of a potential loss there. And then it goes through, these are kind of the risk mitigation efforts, and I kind of think these are kind of things when we talk about bulletin 11 or 12 within UC, when we look at risks to UC or to universities in general, you'd say, okay, well, if we have an issue of disruption because of product location, well, the solution is to diversify locations. IT and infrastructure failures, well, maintain appropriate backup. So you kind of think of what are the mitigation efforts you might think of. That's really what risk managers, whether the organization does or not, the obligation is to bring it up to senior leadership and say, look, we have this as an issue. We should consider da-da-da. Here's the risks associated, the consequences, likelihood of occurrence. You make the decision. On crisis communication, one of the things they talk about here, and I think there'll probably maybe be something, but quality of crisis communication is essential to resiliency. The idea that to be able to get back up in operations to where you were before, you have to have really good crisis communication efforts. And again, probably 10 years ago, you didn't hear much about crisis communications, but it's really becoming, there's more training on it. There's just more aspects that people need to be aware of, how to handle a crisis, who says what, and make sure people don't say stuff that they shouldn't be saying because obviously the media may pick up on some of that.
Well, wasn't that the CEO from BP? His communication was, I just want my old life back.
Yeah.
So we pointed out, well, what about the 11 people who died?
So yeah, good. So the example was given, the gentleman from BP, the CEO, saying, I just want my life back after the disaster occurred. And again, what about all those other people? So it kind of really showed, sympathy or anything else. And again, that's why there's people specifically trained on who talks. They have their whole, they know what to say. I was actually at the SHEMA Campus Safety Environmental Management Association, and it was interesting. The director from EHS director from SeaWorld was one of the keynote speaker. And during the question and answer period, someone asked about how they deal with PETA or people for the ethical treatment of animals, and you could tell he had a very rehearsed, canned response to that very question of how he was. So he was very well trained. It was a very good answer, but you could, it didn't look robotic or sound robotic, but having, because this is what I do, you could tell, okay, yeah, they made sure he knew exactly what to say and how to say it in that situation. So when we talk about stakeholder communication, begins before threats materialize to develop baseline trust. That's what I was talking about with Southwest. Crisis communications begins before there's any threat. You want to have a good relationship. The stakeholders must believe that management will competently handle the crisis, demonstrate that senior management is committed to maintain transparency in the decision-making, consistent and tailored to specific audiences. So that, when we're talking to this one group, we want to make sure it's specific to what their concerns are, and must embody corporate integrity and authenticity of what the values of that organization are. We talked about internal stakeholders, who those are. Employees would be part of that unit, and operational managers need to be made aware. Stockholders, be informed of the steps to manage and mitigate, prevent future crises, and as well as the board of directors informed about strategic exposures, governance issues, things like that. They need to be made aware of, okay, how do we make sure this doesn't happen again? So from a UC standpoint, the Board of Regents would be the ones we want to make sure that they're aware of those. The external stakeholders in crisis communications are suppliers. Deliveries, talk about production schedules, make them aware of, hey, if we have a shutdown in operations, if we're, again, a manufacturing plant, when can they expect to have these things? Are they going to get paid? Might be one of the issues as well. Customers, again, safety and concern and loyalty. If you, Asiana, or if you're another airline, again, if you're Southwest, you have this situation, how do you make sure the customers feel, hey, we're taking care of this? What statements are they making as part of that? Public officials, what are we going to say to them about the efforts to ensure public safety? And again, the media will help transmit that information. That's really the megaphone that's going to be used for it. Obviously, the benefits, improve relationship with internal, external stakeholders, helps protect reputation, promote trust in products, and ultimately, hopefully, minimize litigation in the process. That people again are going to feel okay. They're handling it. They're going to have less likelihood of that. And again, if you treat people well in the beginning, they feel like they're being respected. And this even goes to even work comp claims or other type of things. Someone slips and falls, if you treat them with respect, they're less likely to get an attorney. They're going to say, okay, they feel that, hey, you're going to work with me, and that's what you want to have. So we also look at supply chain, mitigating supply chain, cascading disruptions, supply chain management, and business resiliency plan are some of the concepts you want to keep in mind. So real briefly, I just want to go through this scenario so people are aware. This is the case study. It's on page 3.21 in the textbook. It talks about Bakeries Incorporated that manufactures organic whole grain sesame bread and goes through here. So people don't have to read the whole thing. I made kind of here's the key points in this whole thing. It's mill company. They're a grain flour producer. Which the one thing I did put on there, they buy organic grain from farmers, to supply wheat. Mill company was purchased by a large company, and one of the things they started doing to save money is they decided, this organic stuff that we produce, let's go and mix in the non-organic stuff to save money. Okay, well, eventually a whistleblower, an employee in the company says, hey, calls the FDA. Now there's an investigation because they label as organic, which it's not now. And so it makes the news, and all of a sudden Bakeries Incorporated, which gets all their grain from this company, they only buy it now for their organic bread. They can't find a supplier. This was their sole supplier. They can't find anyone else to be able to do it. So now they're kind of stuck. And then you have down the road, a little bit further, is Health Foods purchases bread from the bakery, from Bakeries Incorporated, and about 35% of the product sales come from this company, which they get. So you can see that the supply chain impact by this one decision now impacts not only the Bakeries Incorporated for their product to be able to sell, but now also the health food store, their sales are going to go down because now they're going to maybe go someplace else. And down below kind of shows the organizational codependencies of how each one of these things is somewhat related there. I just skipped all the way and had some other things in the book, the case analysis and solution. So if the exposure in this case, now we're talking about Bakeries Incorporated. So this is the manufacturer who makes the bread. So they only have one key supplier, which is a financial risk, right? I would say it's also an operational risk. I kind of think that way. But so when they need to diversify or buffer their inventory to make sure that they have enough, when we talk about buffer, they keep an extra on hand in case something happens to the supplier, that they'll have time to find another supplier. Where right now, also the other thing in there they mentioned is the contract requires that they get 3 months notice if they're going to cancel the contract. So now they don't even have a supply. They have to continue buying this stuff and produce a product that they really can't sell in this situation. Small customer base, because they only have the one store that's really buying most of their, how can they get others to buy theirs? Litigation now, they need to renegotiate the contracts with hold harmless clauses, because if something happens, people are healthy foods and who's suing who on that reputation. And then also survival. They need to redefine their strategy of how they're going to, can they survive just making organic only as part of that. The mill company, who is the one that now produces this inferior product or sells the grain, new management and culture, so the type of risk, social, political, legal, how they might handle that, employee meetings, training, change management, how they can talk about that. They have a broad number of questionable suppliers, again, financial, quality assurance program, FDA, adhere to all regulations. So you can kind of see the idea is what's the exposure, what's the risk that we need to consider, and then this is what we might be able to do. And these are very, obviously, broad, simple things that the way they're outlined here, but it gives you some context of, how would a risk manager want to approach some of these different situations when we think about it. And again, this is all enterprise risk management when we think about it, about business continuity. And then healthy foods, again, customer loyalty, how they're going to deal with that because now they're selling this product, things, reputational risk, again, all those type of aspects. So we went through all chapters there. So just a little bit over on time there. If there's any questions, feel free to ask. But otherwise, next week we will be going chapter 4. So only one chapter, and I believe it's on property losses, if I'm correct. Will be the next chapter. I went ahead and put that the next chapter in the Dropbox, so that way people have access. But then that's probably the last one, so hopefully people will have their books by then. And otherwise, I look forward to next week. We do have a couple questions. UC Ready. Someone's asking if UC Ready was Quali. Actually, just the opposite way around. UC Quali is UC Ready. UC Ready is what we provided to the Quali Foundation, and so that is now available to other universities to use. That was our contribution to the Quali Foundation. So with that, I want to thank everyone for a great class, and we will do this again next Thursday.